Hey, how's it going? I'm Kevin O'Connor, a solutions engineer here at HashiCorp, and today I'm going to be taking you through a demo of HCP Terraform Stacks, which is a new capability we developed to help with some of those complex application deployments, whether it be multi-environment or those with interdependencies that often force us into kind of daisy chaining our deployments or following a strict order of operations in order to successfully roll out and deploy our apps. All right, so let's get into it. I'm going to go ahead and share my screen here and we will get rolling. So I like to start off with a couple of questions, which sort of led us into the development of stacks, right? The first one kind of being around those dependencies between workspaces, or, I'm going to say workspaces a bunch today. If you come from the Terraform Community Edition world, you can think of those as kind of individual state files, right? Those would map to workspaces in HCP Terraform. But are there dependencies or an order of operations that really need to be maintained in order to successfully roll out our apps, right? Do you need to deploy, say, landing zone components first before infrastructure and then applications, right? And having to separate those out into their own workspaces and kind of deploy them in order to successfully roll out our app, right? Or within the application itself, are there different dependencies that you've split up into workspaces when in reality, maybe it makes more sense to be able to deploy those things all as a single unit, right? The other aspect here is kind of deploying the same infrastructure config multiple times, right? Where maybe you have different environments like dev, test, stage, and prod. Maybe you're doing multi-region deployments, like an active, to production setup, East Coast, West Coast kind of a thing. Maybe here if you're in the United States, right? Or regionally or globally around the world, right? Or, maybe production in DR, right? And maybe you're kind of having to deploy that same config out to multiple areas. And with the way things are done today, you actually have to have separate workspaces for each of those deployments, and you wind up kind of just copy and pasting your config each time, right? So that's all to say is that we've thought about these topics, and ultimately Stacks is what came out of it, right? So as far as an agenda, kind of just walk through some things here. I'm going to kick things off by going through an application sort of platform example and the complications that result when you try and deploy that using workspaces. Then I'll introduce Stacks and bring that same application example back, and we'll model it out using Stacks. Then we'll actually get into the code, and we'll do a walkthrough of our code because there are new Terraform file types that we'll want to get a handle on. And then I'll demo it, and we'll deploy kind of our real infrastructure using Stacks, and then we'll recap and take questions from there. Okay, so as far as an example here, right? Let's say that we have a web app running on Kubernetes in AWS, right? So we would need several cloud resources to build out our application, right? We, of course, are going to have those landing zone components like VPC, networking, VPC subnets, whatever it may be. And then we're going to have our infrastructure piece. In this case, we're going to be running Kubernetes on Amazon's EKS. And then we'll actually be kind of deploying things onto that cluster, right? So we're going to have a namespace in our Kubernetes cluster, and then maybe some APIs or an application, right? In this case, I'm going to be deploying a custom resource definition API, which we can think of as kind of a front end for maybe a back end application, right? And what we're going to be able to do is define all those resources in the same configuration using stacks so that they can be planned and applied together. So that's kind of end state. Now, looking at sort of historically or traditionally how we would have to do this in Terraform, using workspaces, kind of pre-stacks, right? What might this look like, right? Well, first we're going to have our networking component, right? And traditionally it would have its own workspace, right? So maybe that's our, VPC component. Then we would deploy our Kubernetes cluster, right? And Terraform and Kubernetes can be quite interesting, as you might know, right? We need a lot of other services to be deployed in that cluster for the smooth deployment and operation of our application. So ultimately, we'll want to deploy our services, right? But before we can do that, we may want to enable OIDC in the cluster. But before we can do that, we need to bring up the Kubernetes cluster itself. So there's a lot of these dependencies that would prevent us from deploying this as a single Terraform configuration because many of the sort of prerequisite required resources wouldn't be there. And so we're forced to break things up, Right? We may need one workspace for the cluster and then another for everything else for the other services that we need in order to make Kubernetes operational. And then lastly, we're going to have our workspace for our actual application, right? So this is maybe for one environment, but as goes kind of with many apps, we're going to need to actually deploy them across multiple environments, uh, development, production, testing, staging, QA, whatever it may be, perhaps disaster recovery as well, right? And so we can wind up with something that looks like this, where maybe we have 12 or even more workspaces for a single application. Now, multiply this by tens or hundreds of apps and app teams, and you can start to see how there might be some scaling challenges here. And all of these workspaces would need to be planned and applied in the right order. So we've got a nice little sort of visual animation here, right? Because there's a lot of those dependencies that we talked about before, right? So, you're going to have to run plans, kind of analyze the outputs of those plans before then maybe running the next plan and apply for the next component that it is you're looking to deploy, right? And what's not kind of depicted here as well is all the time that's needed to review the output from each of these plans and sort of analyze all those differences. And as you guys might know, there's really no easy way to track changes across all of the dependent environments. So maybe you get this all set up and it's working great, right? But then you actually want to spin up another environment. Well, you're going to need to plan and coordinate all of this in the correct order again. Maybe you have a run book to do it, right? But maybe it's not well documented. Maybe there's some tribal knowledge as far as, how these sorts of things need to go within your organization. And so as you scale, it becomes increasingly complicated to make it all work. So that's some background, and that's all to say, is there a better way of doing this? And we thought to ourselves, well, yeah, Terraform is great, but can we kind of extend it out a little bit further, make it a little more efficient? And that's what we wound up doing here. So Stacks is going to take your infrastructure as code and actually add another layer of abstraction on it, right? So there's basically a new layer of configuration that sits right on top of your Terraform modules. And there are some new Terraform file types that I'll get into in a little bit, but we're not reinventing everything, right? It's more an extension of the concepts that you're already using. So we're taking those Terraform modules and using them as a foundation for a workflow that's going to help you better organize and deploy them. So a stack will essentially let you deploy multiple root modules and then deploy them multiple times, all within a single config. So having said that, let's get into some of the key concepts of stacks. First up is a component, right? And a component is essentially what it is that we want to deploy. So the component's kind of the what, right? And each component is going to map to a top-level Terraform module. So an example would be that we have a networking component, a storage component, a compute component, right? That all map to modules that I have for each of those individual aspects of my stack, right? And they're going to let us components, allow us to more or less logically separate our infrastructure into smaller parts with interdependencies. And these are typically going to be the sorts of things that, we want to plan and apply together, right? So when we're thinking of what goes into a component, it's going to be things that share a life cycle as far as updates and versioning and deprecation and that sort of a thing. So when you see component, today you can kind of map that to modules that you've already pre-written, and a component is more or less kind of a wrapper around those. Then we have our deployments, right? So if the components are the what, the deployments are kind of the how or where it is we're going to be deploying our components, right? So this is kind of essentially how many times we want the collection of components to be deployed. Right? And this is going to allow us to repeat our infrastructure without repeating our code. If you're familiar or have heard of the dry principles of coding, don't repeat yourself. That's what this really plays into. Right? So now you don't have to reuse the same config across multiple workspaces and worry about swapping out variables and that sort of a thing, dealing with TFRs files multiple times, right? So deployments will really be a native way to accomplish this from within a single stack. And then, as you can imagine, and as you'll see in a second, there's sort of this cycle of kind of multiple plan and applies all within a single deployment when you're dealing with stacks. And so manually reviewing and applying changes across several repeated infrastructure instances can start to become a bit tedious. So if you're deploying on the scale of hundreds or thousands, you can implement orchestration rules like auto-approving a deployment plan if it meets the criteria that's defined in the checks. So if you're familiar with check blocks within Terraform, orchestration rules essentially allow you to use check blocks to automate some behaviors, right? As long as they are passing checks that you're, evaluating conditions on, then the orchestration rules can either sort of approve or deny, based on those checks, right? One last thing, the concept of deferred changes, right? And this is the one that kind of helps us get around those chicken and egg situations, like what I spoke about before, with our Kubernetes deployment. It allows you to essentially delay some executions of your deployment until a later time, essentially for those situations when a prerequisite resource needs to be available during a deployment, right? So what this looks like in practice is that you can start out by making an infrastructure change. Terraform will realize it doesn't have enough information to plan and apply all of this right now. So instead of failing, which is what it would do today if you tried to deploy this all within a single workspace, Terraform is going to split it into a few parts. And it's going to take everything it can plan right now and put that into plan part one. And then it'll save the things that it doesn't have enough information for later on and defer those changes. We'll then apply plan part one. That'll give you a bunch of outputs, right? And Terraform will take those outputs and be able to kind of input them to be able to run plan part two, and then you'll plan part two and apply part two. And it'll continue that sort of cycle until there's a final convergence check where it basically says, is everything that's been deployed match what the intended config was? And if the answer is yes, then our deployment is successfully applied and complete. So what would this look like in practice using the example we laid out before? So similar to workspaces, right, we'll start with the core networking components, and we're going to group things together again that share the same life cycle. So we'll start with the VPC and then progress to the EKS component, which includes resource definitions around the Kubernetes cluster we're deploying. And then perhaps we've got other parts of the Kubernetes deployment that's needed, including permissioning and IAM. Right? And then within Kubernetes itself, we'll be deploying a namespace where the app will live. And then let's say we're deploying our actual application. In this example, we'll be deploying a custom resource definition API, which for simplicity's sake, we can think of, again, like a front end or an interface, right, for interacting with our backend application. And now this is what we're going to call a deployment, right? Because ideally, we want to deploy all of these things at once. But again, if we tried to do this within a workspace, we would get a failure. And the main cause, being that the API we're looking to deploy on Kubernetes really needs other Kubernetes components to be deployed successfully first. There's also some other things in here which we'll get into, like the Kubernetes provider config actually needing output values from the cluster component, right? Meaning that it's going to defer the initialization of the Kubernetes provider until after the cluster has been deployed. So there are some other interdependencies there, and I'll show that here in a minute. But for simplicity's sake, when you think about this, the easiest way to think about it, at least to me, is like, hey, we can't deploy an app until we have the infrastructure available. And in the old model, we'd have to separate everything out into their own workspaces and manage those dependencies on our own. So here again, right, we have that idea of deferred changes, right? Because Stacks is going to understand the dependencies here, and it'll defer deploying certain resources until it has the information it needs to be able to plan and apply them. And then the other great thing, as we mentioned before, is that our deployments, right, we can kind of specify additional environments where we want these components deployed. So we won't be deploying it just once. We'll be doing two environment deployments at the same time, right, for development and production, and just calling it out twice in our deployments file. So having said that, let's jump in and take a look at our code. And we can see, oops, just collapse that. We've got a few different file types within here. We've got a components.tf stack file, deployments.tf deploy, providers.tf stack, and variables.tf stack. So let's start off with the easy one. Variables looks fairly similar to what you're probably used to today, right? There's nothing really new within here. So let's jump into the providers .tf stack file. And we can see that we have our provider blocks for AWS and then Kubernetes as well too, right? And you'll notice one of the callouts is we have some inputs for our Kubernetes provider here. And this is what I mentioned before, where we actually need outputs from our cluster component in order to successfully call on the provider for Kubernetes here. So I'll provide a little bit more detail on that in a second, but that's one of those dependencies that Stacks is going to handle for us. Then we have our components. And we can see, like our Terraform config, we can organize our stack configuration into multiple files without, affecting the resulting infrastructure, right? So I've got this cluster component where I'm defining, or I'm calling out to a cluster module that I have, and then I've got this cube component where I'm doing the same thing, right? And we'll pass inputs in as well too, at the cluster level, right? So there are some parameters. You can obviously give your users the option to customize their components, right? But you might be saying, looking at this, like, hey, these just look like module callouts. And I kind of alluded to that before, and you'd be right if you were thinking that way, right? They're essentially just wrappers around modules. So I've got, again, we can see the source parameter here. I've got these defined locally. So these are like local modules. However, you could call out the source into private module registry if you're using that, or any Git repo that you have. All right. But looking at these components and where they're sourced from, the modules that I have, you can see they look kind of like a typical module, right? We have a main.tf in this case. This is essentially where we're defining our EKS cluster that we're going to deploy. We have the VPC components in here as well too. Right? So kind of our landing zone components for the VPC and AWS. We have some things around RBAC and permissioning for what the EKS cluster is going to need to function, right? So that's kind of like the landing zone and infrastructure base components that we have within our cluster module. And then we have this cube module as well too, where we are doing things like deploying our Kubernetes namespace, the manifest within Kubernetes, and then our CRD, which is essentially the API that we're deploying on top of Kubernetes. So this we could think of as our application component. Right. And again, if we take a look back now, it might make a little bit more sense at our providers.tf stack file, right? We can see, those inputs for the Kubernetes config are going to be coming from the cluster component, right? Once this cluster component is stood up and deployed, then the Kubernetes provider will have the information needed in order to run properly, right? So at runtime, Terraform is not only going to look for the inputs and outputs across components in my stack, but also at the providers as well, right? And it'll use those to determine the graph of dependencies for the order of plans and applies, right? And that's really an important first step in working around some of those dependency headaches that we might have had before. Last thing to take a look before jumping into the UI is our deployments file, right? Which can include essentially one or multiple deployments based on the environments we need, as well as kind of authentication specifics for our stack. So here we can see we've got a development deployment and then a production deployment. And you might be wondering, do I need to use the same authentication method across all of my deployments? And the answer to that is no. You could use a different, AWS account. You could deploy your deployments into different AWS accounts if you wanted to, right? And so the way I was able to set this up, this authentication, was first in establishing a trust relationship, an OIDC trust relationship between HCP Terraform and AWS. And I actually did this. If we break away for a second and go into Terraform Cloud, I actually did this within using Terraform. So I defined what was needed for the trust relationship to be established. I have variables for AWS access that were used to set up that trust relationship. And then back in our code, we're able to then call out a few different things, right? So we have our identity token block up here, which essentially declares a source of identity credentials. In this case, AWS is indicating that AWS will be the provider of the identity token. And then we have the audience of AWS workload identity, right? Which really specifies the intended audience or service for the token, right? And here we can see, it's set to AWS workload identity, which signals that to AWS that this token is meant for their workload identity federation capability, right? Then within our actual deployments, there's a couple things that we're calling out, right? We have this identity token parameter. We can see that in both blocks, where identity token is set to the identity token AWS jot, so kind of calling up above, right? So this is referring to the JSON web token that's generated through that identity token block up here, right? And so by using that token, the workload in our deployment is going to be able to authenticate securely to AWS as an identity with the privileges that are associated with the Amazon resource name or role ARN that we specify, right? So at runtime, what's going to happen is it's going to expose a jot that I can directly pass into my deployment along with the role ARN, and those will get passed into the providers that we were looking at earlier, right? So that's all to say that this setup is helpful for using short-lived automatically rotated tokens for my deployments access into AWS instead of needing long-lived access keys, right? Which is really going to help us improve security by reducing static credential exposure for each of my deployments. Okay, let's hop back into the UI and kind of give you a better visualization of how this all works. So the first thing I like to call out is that I'm at the I'll go back one more. So I'm at the project level right now. I have a project called Learn Terraform Stacks Deferred Actions. And we can see that we have a workspace set up and then we have a stack set up, right? So this is the first call out that I like to make, is that a stack is completely separate from a workspace. It's kind of like a cousin in some sense, right? It's not as if you're deploying a stack within a workspace. You're deploying a stack and it's its own entity, right? Now I have a workspace, as I mentioned before, that I set up here in order to establish that OADC trust relationship between HCP Terraform and AWS. But I don't have any stacks yet, right? I do have all the code that we just looked at. I do have within my personal GitHub repository, right? So if we go ahead and click create a stack, it's going to give us the option to link to a GitHub repo that I've kind of pre-established a relationship with. And we can go down and find that code, which is in a repository called Learn Terraform Stacks EKS Deferred. We can leave all of the options at their defaults, and we'll just go ahead and click create stack. And from here, we can see it automatically begins kind of preparing a new configuration. What this means is that HCP Terraform is pulling out the latest commit in that connected repo and parsing out all the related deployments in it. Right? And it's going to start queuing plans for each of the deployments that we have in our stack. Right? So we've got a development deployment, we have a production deployment. Both of those will get populated here. And there we go. Yep. So now we have our deployments for development and production, and those will queue plans in a second as well too. If we head into, so let's go into configuration one, we can see we've got some information here. We can see the latest commit, right? So this was from me, this is the commit message. I removed some orchestration rules, when it was committed. If we want to actually look at the commit within GitHub, that's linked out here as well too, right? So we can see that. If there were any dependencies, those would be listed here. And because my modules are all being sourced locally, there's no outside dependency, right? But if they were hosted in a connected Git repo, if we were sourcing modules that were stored in repositories, they would show there, right? And now we can see if we roll down, we have plans queued for both my development and production deployments, right? And we're just going to take a look at our development deployment today. Go ahead and click into plan one, and we can see that plans in the stack are broken down by component, right? Which is a great way to segment the changes. So we have the cluster component plan and then the cube component plan, right? And expanding this out, you can see that this diff is probably similar to what you're used to with Terraform, right? And again, these are all of the cluster components that we're going to deploy. And then you can see that we have a notification here that we have deferred changes, right? This plan includes resources that cannot be planned until some other resources are applied. After this plan is applied, automatic follow-up plans will process these deferred resources as they become ready until the deployment has matched the configuration. Right? So again, that's basically telling us we're going to run through this cycle of plans and applies until the deployment matches the config that we have. If we take a look within our kube component here, let's just take a look like at the namespace, for example, we should have some more information. Yeah, and it tells us, okay, hey, the provider configuration for this resource contains unknown values. So the resource instances cannot be planned. That's exactly what we were talking about before when we looked at the Kubernetes provider, right? Because it was sourcing inputs from the cluster component, if we remember. So the cluster component needs to be deployed first, and then we'll have what's needed in order to run a plan for our Kubernetes namespace, right? So that's essentially what Stacks is telling us. It's saving that plan for later when it's ready to do things. Now, the way that I have this set up is currently through manual approvals for our plan and apply. Right, so I would actually have to go ahead and click approve plan, and we're going to do that now. Again, you can use orchestration rules to automate some of this. So taking a look within our code again, I had commented out some orchestration rules here. This is essentially the structure for how they work, right? So you have your orchestration block, and within it you can have a check block where you're evaluating certain conditions, and then if they pass or fail, you can have kind of actions be taken on them, right? In this case, this orchestration rule would auto approve development environment deployments if no resources are being removed, right? So maybe you want, you don't need to go through some serious, kind of process of checks for people just rolling out development deployments. You want them to just be able to do it. And so you would kind of auto approve those or that using orchestration rules, right? But check blocks, if you're not familiar with an HCP Terraform, can be used for a number of things. You can check for the existence of pre-existing resources, if a load balancer or API gateway endpoint is reachable, ensuring proper DNS resolution, right? Checking that a DNS entry resolves to the expected IP. You can validate security group rules, right? Check the status or the health status of load balancers, just monitor application status, right? There's a number of different things there that you can do. So this plan is going to take a little bit, right? The EKS cluster is going to take some time to get stood up. If we actually look out here within AWS, we might be able to see something. Yeah, so this is being created right now, which is great. One other thing, take a look at our plans within development. So question that's come up before is, well, how does this affect state, and like how do state files work with Stacks? As you can see here, they're actually maintained at the deployment level, right? So we have our single stack config that has development and production, and each of those are going to maintain. So this is our development deployment state history, right? So we're going to have all of our state versioning being done at the deployment level. So just figured that's worth a call out as well too. Now, head back into one other call out as well. If we go back, we'll see, right? So our configuration, as our configuration changes, let's say our team, someone wants to edit the code, they make a pull request, or they edit, they make a pull request, it's committed back to our master branch. Well, Terraform is going to pick up that the configuration has changed and want to roll out those deployments. All of that versioning is going to be shown here as well too, right? So this is our first configuration, right? But then as we make changes to our code base, that will be our second configuration and third and fourth and so on. Those will be versioned here in the UI, right? So you have kind of a quick view into what all of those look like. But as far as, naming convention, right? Config 1, config 2, config 3 is how Stacks is going to keep track of all of that. So let's take another peek real quick at our plan 1 apply. And what I'm actually going to do here, because this will take a few minutes, I'm just going to pause the recording, and then we will pick things up once this first part of the plan is complete, to show you what the kind of plan 1-2, right, or the second part of plan 1 looks like. Okay, so I'll be back here in a jiff. Okay, and we are back. So we're in plan 1 right now. We can see plan 1 has been successfully applied, and it created a convergence check that it's calling plan 1-2, right? So the second part of plan 2. Now let's go ahead and we'll go ahead and check that out, right? And just to show you how this works, right? So now within development, we've had plan 1 applied, and we now have plan 1-2 that's waiting on approval. Again, it looks like we have some deferred changes as well too. It's giving us similar message as before that after this plan is applied, there will be automatic follow-up plans as well too, to be able to deploy those deferred resources as it can, right? So let's take a look within here, and we can see that it looks like the Kubernetes manifest and namespace are going to be able to be deployed if we open the diffs there. But now within or excuse me, the manifest CRD, the Kubernetes manifest resource itself contains unknown values. So that resource cannot be planned for, right? So essentially what this is telling us is the Kubernetes manifest CRD and Kubernetes namespace can be planned and applied. And then after we get the outputs from those resources being applied, it sounds like we should be able to deploy our Kubernetes manifest resource, this one in the middle as well too. So let's go ahead and approve this plan. And we'll hang on the line this time because I think this should be a bit quicker. And we can take a look as this handles its plan and apply. And something while we are, this should kick off here in a second, right? While we are, there we go, we can see it's running. While we are waiting, I'll just make note that our production deployment, there's no need to really go through with this one. You know, the config is the exact same as our development deployment, right? So we would follow the same plan and apply steps that we went through before, but just wanted to call it out that, you know, this is kind of how it would look if you have multiple deployments within the stacks, within stacks itself. So plan 1-2, see, that was pretty quick. Applied successfully and created another convergence check for the third part of plan 1, what we're calling plan 1-3, right? And we can see these were successfully deployed. Great. Fantastic. We have a timeline of what's going on. Now let's view the convergence check plan for plan 1-3. And we should have that middle resource component, which was for Kubernetes manifest, right? And we now have the information needed in order to plan and apply. So we're going to go ahead and approve this plan as well too. And this should just take a few seconds as well to roll out once the run or the apply gets going, which it looks like it is. Plan 1-3 is applying. And then what we're going to get, because I think this should be the final resource that needs to be deployed, we should actually get one final check and what they call the final convergence check, just to make sure that everything that's been deployed actually matches the intended config, right? So let's look here. Okay, we're done. We can see plan 1-3 is complete. We have deployed that final resource, and then we've kicked off that final convergence check for 1-4. We can look there, and it is just doing its final check, right? There should be no real changes, and we should have an apply complete. And there we go, right? So plan 1-4, no changes, right? We're all good. Everything matches. The configuration is now fully converged, which is fantastic and what we were looking for, right? So that is it. Just to recap, right? We were able to deploy to multiple environments using the single stack config, right? And Terraform is able to plan changes across that single config, really deferring changes when it didn't have enough information, and then going through that cycle of replanning and applying until everything is converged, right? Some of the main benefits, if you haven't been able to glean at this point, right, are really around scalability, right? Being able to spin up new regions, having kind of easier tenant isolation, and really having that new config structure, empowering your users to deploy, repeated pieces of their infrastructure multiple times, right? And then having some of those orchestration rules that you can bake in to kind of avoid unneeded manual reviews. Stacks really gives you improved visibility as well too, right? So now within a deployment, right, you have kind of a single place to view and identify and address issues within a single deployment, right? Whereas traditionally, a lot of these components would need to be split up into their own individual workspaces, and you would have to kind of track changes across them. You would have to troubleshoot errors individually within each of the kind of single workspaces themselves. Now you have sort of a single place to manage a true deployment from the most basic piece of infrastructure up to the final application deployment. And that last point really touches on consolidation, right? So there's no more need to split up infrastructure and target workspaces individually. There's kind of less time on coordination and more time on actually monitoring the rollout of changes. So that'll do it for me. Thank you for listening. If you made it this far, please feel free to reach out to myself or your account team if you have more questions on Stacks. Aside from that, tons of docs and tutorials online. Head to developer.hashicorp.com. You can just search for Stacks. We have tutorials. If you want to run through this yourself as well too, we've got a great step-by-step tutorial that'll hold your hand through the entire thing. I'd urge you to go look there as well. But if there are no more questions, that'll do it for me. And thanks so much. Have a good day. Bye.